Hello students and welcome to the second chapter of 21 SMSC 234B. The name of the chapter is the chemical screening and microcrystal tests. Chemical screening methods are theoretical or tentative tests which are commonly used to initiate the process of substance identification. These simple chemical reactions cannot identify the substance, but they can provide preliminary confirmations of the presence of either a particular functional group or a generic molecular structure. The chemical screening tests produce a distinct color when the reagents are mixed with compounds containing a specific functional group. Though these preliminary tests are not highly specific, but they will help in determining which subsequent method can be used to identify the substance. The chemistry of color formation is very interesting. As we all know, visible light contains a mixture of wavelength in the electromagnetic spectrum ranging from the approximately 350 nanometer to 750 nanometers. If some of these wavelengths are removed from white light, it is no longer observed as a white. In chemical screening reactions, a characteristic color will be produced when a screening reagent removes an electron from the test compound. As you can see in the figure, a colored compound or the molecule will contain 8 electrons in its outermost octet. The reagent will remove one of the electron, which will lead to the transition of the electrons, and it ultimately leads to the color formation. Similarly, a color can also be produced when a screening reagent adds an unpaired electron directly to the test compound, or there is a possibility that the screening reagent complexes directly with the test compound, resulting in the addition of an unpaired electron. In some cases, a screening reagent bridges two or more test compounds and it will form a complex which will produce a color. Though these tests are very simple, specific, they give a clear idea about the functional group or a particular class of compounds. It has number of limitations, like the color screening tests are non-specific. Different compounds can produce same type of color, so it will be difficult to differentiate the compounds or the different drugs based on this color formation. They are only used to confirm the presence of either a functional group or a characteristic structure. They cannot be used to positively identify any substance, and they cannot indicate the presence of a specific class of compounds. Apart from number of limitations, these chemical color tests are routinely used in the forensic laboratories because these tests are very simple and rapid. The quantity of the reagents and the sample required is very less, and these tests are generally performed in a clean spot plates or the culture tubes. The few milligrams of the sample is placed in a spot plate or the culture tubes, and the few drops of the chemical color reagents are added, and if any color change is there, it is recorded immediately. The procedure is continued, and the few drops of subsequent reagents are added and the colors are recorded if the test require more than one reagent. And along with the sample, a positive control and the negative control is also run so that the color can be compared very easily, and from the color formation the type of the control substance can be identified in the. A comprehensive documentation of a chemical color test should include a complete description of the reagents and the test substance, like its color, physical properties, irregularities, identifying characteristics, and the photographs, etc. All the observations which are noted down during the test performance should be included in the documentation along with the photographs so as to prove the presence of a particular compounds. A complete description of the results, like final color, positive or the negative comparison, to be published, results, deviations, supporting evidences, results, and photographs should be included in the documentation so as to create a proper record and to decide the suitable analytical method for that particular drug present in the sample. These are the few chemical tests which are routinely used in the forensic laboratories, and these are very important, and these are specific to the particular type of control substances. Like this Marquis test is specific for amphetamines and other alkyl aminoketones. The Dili-Kopianis test is specific for barbiturates. The other important tests are chains test, mix test, nitric acid test, primary amine test, which is specific for the presence of amino group in the control substance. There will be a test for secondary amine group, tertiary amine test, Van Hook's test, etc. For example, the Marquis test is very important test for identifying a control substance or the narcotics in the sample. It involves two reagents. The first reagent is concentrated sulfuric acid and the second reagent is 37% of formaldehyde in 10 ml of glacial acetic acid. The procedure is very simple. We have to take 1 to 2 milligram or 1 to 2 drops of the sample in a spot plate. Then we'll add 1 drop of reagent 1 and 1 drop of reagent 2 and we'll mix it. As soon as we mix, we will note down the color. If there is a orange to brown color is produced in the spot plate, it will indicate the presence of N,N-dimethylamphetamine, amphetamine, methamphetamine, mescaline, and the threading group. Similarly, if we get purple color, it indicates the presence of opioids, morphine, heroin, and codeine. For opium, generally the brown to red color or purple color is obtained, and if methadone is present, it will give pink to violet color. There is a shades, different shades of the colors will be obtained based on the concentration of the compound. The purple color, which is formed due to the presence of opioids in the sample, is most likely from a complex containing two molecules of the opiate and two molecules of the formaldehyde. As shown in the reaction, there will be a complex formation in presence of acid, and this bimolecular orange to brown colored carbonium ion complex is formed between the two amphetamine or methamphetamine molecule in presence of Marquis reagent. This is a general example which is shown by taking amphetamine and it is reacted with formaldehyde in presence of sulfuric acid and it forms a complex which is purple in color. The second important test is Deli-Kopianis test, which is generally specific for barbiturates and it also includes two reagents. The first reagent is a mixture of 0.1 gram of cobalt acetate and 0.2 ml of glacial acetic acid in 100 ml of absolute methanol. The second reagent is prepared by dissolving 5 ml of isopropylamine in 95 ml of methanol. The procedure is same. We have to take 1 to 2 milligram or 1 to 2 drops of the sample in a spot plate. We have to add 3 drops of reagent 1, then 3 drops of reagent 2, and we have to note down the color. There will be a formation of purple color if the barbiturates are present in the sample. And the blue color is generally formed by the formation of a complex between barbiturate and isopropylamine as shown in the figure. The another technique which is called as the microcrystal technique is also one of the important and sophisticated technique for the identification of the narcotics and psychotropic substances in the sample. These microcrystal test techniques are based on highly developed chemical precipitation reaction in which a polarized microscope is used to observe and distinguish different types of distinct crystal form. Most of these tests were developed in the late 19th century for the identification of the alkaloids, and as the time passes, they have been modified and are accurately used in the identification of a majority of the control substances. These microcrystal tests are the confirmatory techniques often used to verify the results of preliminary screening method or preliminary chemical tests. These tests are fast, easy to perform, and can be highly specific. And the modern forensic chemists use these microcrystal tests as a preliminary screening tool. There are a number of advantages of microcrystal techniques over chemical screening methods. The first advantage is that microcrystal tests are a low-cost alternative to GSMS and FTIR that are recognized by the scientific community. The microcrystal tests are safe and are environmentally friendly. In most of the cases, the entire analysis can be performed with as little as a single drop of the reagent. This is in contrast to the volume of chemicals required to prepare a sample for the instrumental analysis. For example, merely 2 ml of the organic solvent is generally used in the sample preparation for the automated FTR analysis, and which is roughly 40 times more as compared to the microcrystal test. The purification of the controlled substances is not required for microcrystal techniques. Diluents and impurities generally do not interfere with the crystal features used in the identification process, and a clear advantage of microcrystal test is their use in the detection of optical isomers. Apart from the number of advantages, the microcrystal techniques has some disadvantages also. The principal disadvantage of microcrystal testing is that it is not applicable to all substances. The amorphous substances do not crystallize, therefore they cannot be identified by using this technique. The microcrystal testing can produce more than one type of arrangement depending on the amount of solvent, the time which is required for the crystal formation, etc. The presence of additional crystal forming agent may interfere with the precipitation of the target compound, and this interference may cause either distortions or variations in the expected crystal forms, which is called as the polymorphism. And this polymorphism can complicate the identification process, and the identification now will be required purification either by thin layer chromatography or any other suitable recrystallization technique. The speed of nucleation process can also influence the shape of the crystal. Crystals with definitive features are formed very slowly, while those formed rapidly can mechanically trap the undesired particles like solvents, impurities, diluents, etc. And these trapped particles can distort the overall structure of the crystal and complicate the identification. The microcrystal testing is a manual technique, and the individual handling of sample and reagent require a care and consistency. The analyst results must be reproducible for the definitive identification. These are the some examples of the crystals which are obtained in microcrystal technique, and these are generally referred with different terms. For example, the crystal will be called as a blade if it is of this shape. Similarly, if we get bunches of the crystals, it will be called as the bunch or the bundle, and it will be the cluster with the majority of the crystal lying in one direction. We can get a hedgehog structure, which can also be called as a rosette. Clusters will be obtained, which are nothing but the loose complex of the crystals. We can get the crystals of the cross shape, and it will be labeled as the cross. And if the crystals are of this shape, they are called as the dendrites. And these dendrites are the multi-branchiates branching crystals. There are some reagents or the tests which are specific for microcrystal techniques, and by using these reagents we can get a specific type of crystal in case of identification of the control substances. The protocols for microcrystalline technique includes recommended procedures for the preparation of a vast number of reagents and solvents and are readily available in a variety of scientific publications. Whereas very few and the characteristic tests are used for the identification purposes. For example, gold chloride test is generally used for the identification of cocaine, in which 3 gram of the gold chloride is dissolved in 100 ml of water and 0.25 of concentrated HCl is added. When the cocaine is recrystallized by using this gold chloride test, it forms the crystals of cones and rosette shapes. Similarly, if the platinum chloride reagent is used in the platinum chloride test by taking 5 grams of the platinum chloride in 100 ml of 1 molar HCl, the cocaine will form the cones of the needles. Similarly, the other narcotic compounds and the psychotropic substances We can identify by their crystal formation by using a specific test reagents. These are some more examples of the aqueous test reagents like gold chloride in phosphoric acid test, mercury iodide test, potassium permanganate test, mercury chloride test, and sodium acetate test. So these chemical screening tests and the microcrystal techniques are very important, and these are the preliminary tools for our forensic chemists. By using this test and this technique, the chemist is able to identify the probable presence of a particular control substance. And depending on the results obtained in chemical test and microcrystal technique, the suitable analytical procedure can be designed, it can be framed, and the compound will be identified. For the detailed notes of this chapter and the question bank, the link is provided in the description box. If you have any doubts, feel free to comment. Thank you.